Today we'll discuss how to make beautiful visualizations using Matplotlib. We'll talk about chart anatomy and the details how to code to get beautiful charts. Before moving on to chart anatomy, please subscribe to my channel to get videos as they are published online. So here you see the chart with its basic components. On the upper part there is title, which in this case is called my random numbers. You can see here also vertical and horizontal axis. Vertical axis has a label which is called my y-axis. The same for horizontal axis. We have also here a horizontal axis label which is called my x-axis. Every axis has ticks on it, and there are bigger ticks and smaller ticks, which are called major ticks and minor ticks. So here you see the major tick and you see the minor ticks inside major tick segments. There is also label, not label, but legend on the chart, which describes the line plots, scatter plots. It makes the user to understand the data inside the chart. So all these elements are included in figure. Here you see the line component, and on the upper part you see the markers. And all these components are included in figure. Inside figure, you can see the axis component, which includes all the functional elements of the chart. You see here in red the axis component. Do not mix it with axis with I mean the horizontal and vertical axis. You can also play it with the styles that Matplotlib offers, and you'll get very nice charts. So let's move on to how to construct single plot in Matplotlib. First of all, we need to import several libraries. For data generation, we need Numpy. We also need two imports from Matplotlib. First, we import Matplotlib pyplot and name it plt, and then for style setting, we get into the program plain Matplotlib. So you see here this line of code is for style setting. Here we set style to ggplot. Ggplot is a very famous type of plotting which came from R programming, particularly from ggplot2 plotting library. So we create here several arrays. First one is consecutive numbers of size 100, and next two are random numbers which again have size 100. We'll use them in different plots. So here you see the finalization of random arrays generation. And on this line we create figure and axis. We create it by using subplots function of pyplot sublibrary, if we can call it in that way. So we create plot by using plot function and first passing the x-axis data, which is here the data, then y-axis data. Then we specify main attributes of the chart. Here we name the color as red and also create the label, which will be displayed in legend. So please see the chart. You see here that our chart does not have any decorations, titles, x-axis labels, y-axis label, and then let's create them. We create x-axis label by using setXLabel function or method. We name our x-axis label just in plain way, x-axis name. The same way we'll create the y-axis name. Here the method is setWhileLabel. And let's see the result. You see the labels that are displayed on the chart. You also maybe have noticed that each time we have different line plot, it's because we have every time random number generated. You see here that we displayed legend on the chart by just using the legend function. We can set the title by setTitle method, and here our chart title is my chart title. Let's see on the chart. You see the my chart title on the upper part of the chart. Let's add another data series on the chart. We want, in addition to the line chart, to have bar chart on our plot. The same rules apply for bar function. That is, for the first is x-axis, second argument is y-axis, and then the attributes, color, label. So you see the blue bar chart, and also on the legend you see its label of bar 2. This is a simple chart, and on the next section we'll move on to creating a plot with multiple subplots inside. First, we need to create a figure. We do so by using figure function and pass here fixed size argument to control the size of the figure. Here our figure is 20 by 9. Then we specify where the subplot should be located. 2 by 2 and 1 argument says that we have a 2 by 2 figure and the plot is the first one and it's located on the left upper part. Next, we specify the plot by typing x.plot and inside it the x and y arguments, and you see here the plain plot on the left upper part of the figure. Then it would be useful to decorate our plot with x labels, y labels. Here we specify our x label as x-axis 1, then y label, y-axis label as y-axis 1. And in the next step, we'll set the title with setTitle method, and the name of the chart will be chart1. So let's move on to create another type chart. Here we want to create a bar chart, and we specify that the subplot should be located on the right upper part. That's why we specify 3 2's as an argument to subplot. That means 2 by 2 and the second chart in this figure. So for creation of bar chart, we use bar method and pass data as x argument and data are to consume as y argument. We copy the decorations from the previous chart to save time. Adjust axis because this chart has a different than the first one axis, and you see the bar plot here with all necessary decorations. Let's continue and create a pie chart. Create a pie chart first by specifying its place on the figure, which is the third plot on 2 by 2 figure. It's the left downward figure. We create a pie chart by using pie method or function here, and we also, as pie chart uses limited type of data, we just slice the first 4 members of the data array and also specify which slice will explode. You'll see on the chart what explode means. So we want the second element to explode by 0.2 value. Here you see the blue slice exploded here. And next we'll specify the labels for the slices of pie chart. We just name them on plain way. First, second, third, fourth, fifth. To be visible, we'll move the labels part to the next line. It's a very useful practice in programming. So you see the labels of the chart here. Next, let's decorate the pie chart with title. It does not have axis labels. Next, let's create another chart, the fourth one in the plot. All the necessary decorations are updated for the fourth plot, and you see here it's the fourth plot on the 2x2 figure. You see that's the same as the second figure, as we have copied all the code of the second figure. So you have noticed also that all these charts, all these subplots overlap with each other. Their charts, their titles and x-axis labels overlap with each other. That's why we need to adjust the horizontal and vertical spaces between the charts. Here we specify all the necessary arguments here. You see no overlap between the titles of the downward plots and x labels of the upward plots. Let's change the color of our chart. It was red, now we want it to be blue. And also, let's change the type to scatter, to have only markers inside. Next two decorations are also very interesting. We can change the line style of the first plot. We can type it by using line style argument, and we have here the dashed plot style on the first plot. This attribute is very important for me because I use it a lot during my work practice. This is like creating a vertical span on the chart. So we created by ax vspan function, and you have seen there the blue span. But as it's not much visible, we use the alpha attribute to make it more transparent. Next, we can put the horizontal or vertical line on the chart. Here we use axHline method, and we want the horizontal line to go on the y-axis value of -5. Next one, we can put text on the plot, and they can be dynamic texts, which change their position based on the data. We use the annotate function here. First, we pass as an argument the text we want to be displayed on the chart, and then by xy and xy text arguments, we specify the place of this text on the chart. So you see on the fourth plot, this is my scatter text on the chart. Let's continue to figure styles in Matplotlib. During lecture, we have used the ggplot style, which you see on your screen. Let's change the style. To get all the styles available, we type matplotlib.style.available, and we see all the list of all the available style. Let's change the style to Tableau related to called Tableau colorblind 10 style. So you see the style on our chart. Let's try another one, Seaborn white grid. You can copy it and paste it on the matplotlib style.use. Interesting style also. Trying 538 style. You see the results on your screen. It's a matter of taste. Which one is better? Let's see the BMH style. Colors are a little bit different. Let's try the plain one, the grayscale, which after these colorful styles will be somewhat strange. It's like Excel 95 style.